So starting with the first question. The first question is that you have. Please keep a calculator with you. The first question is, what mass of solid residue? These are MCQ questions. So what mass of solid residue can be obtained from the thermal decomposition of calcium nitrate? Do you know what the equation for calcium nitrate decomposition is?
No.
Now, if you have calcium nitrate, remember all nitrates, and since group 2 nitrates are in your syllabus, remember all nitrates are going to decompose in the same way. They're going to produce three things. One of them is calcium oxide, a metal oxide. The other one is NO2. And the third thing is that they're going to produce oxygen gas. Okay, so any metal nitrate, it's going to decompose in exactly the same way, specifically group 2 nitrates, because that's in your course. Group 1 nitrates decompose differently, but they're not in your course. So he's saying that 4.1 grams, right? Now, 4.1 grams of calcium nitrate. Which one do you think is the solid residue that is obtained out of these? Which one is the solid residue?
Is it CaO?
Because that's CO. So you're basically looking for the moles or the mass of CO. He's asking for the mass of the solid residue. So what did I tell you about moles questions? That you find the moles of one thing, you can find the moles of everything in the equation. So whose
Yeah.
moles can you find out?
The calcium nitric oxide.
Nitrate.
Okay.
So you can find the moles of calcium nitrate, right?
Yeah.
So can you try and what's the mass? 4.1.
Yeah.
And what's the MR? Can you calculate the MR of calcium nitrate and tell me what the value is?
For the MR, I got 256.
Acha, how did you get 256? It's I I think it's I think it's 164 because calcium is 40, right?
Yeah.
And NO3 twice. N is 14 plus 16 times 3, and NO3 is twice.
Yeah.
So 16 times 3 is 48. 48 plus 14 is 62. Then you multiply the whole thing by 2, that's 124, and you add 40 to it, that's 164.
Yeah.
So it's going to be 4.1 divided by 164.
I got 0.025.
So you got 0.025 moles of this, right?
Yeah.
And the moles of calcium oxide are going to be exactly the same because it's the same ratio, right?
Yeah.
So tell me the mass of this thing now.
Um, I got 1.4.
So you're getting 1 point,
4.
so 1.4 is the answer, right? It's B. And the next one, but remember, all nitrates are going to be decomposed in this way. Whether it's not all nitrates, group 2 nitrates. That's the only thing that's in your course. Um, then he's talking about the next question. In the next question, he's talking about the combustion of fossil fuels as a major source of increasing atmospheric carbon dioxide. Um, then he says that another significant contribution to carbon dioxide levels comes from the thermal decomposition of limestone. Remember, limestone, it's a word that's frequently used in chemistry. Limestone is calcium carbonate.
Yeah.
And calcium carbonate decomposes, carbonates also decompose. They produce calcium oxide exactly the same way as that produced calcium oxide, right? Except that there is no NO2. There's going to be carbon dioxide gas that's going to be produced. So so you have to remember the decomposition of nitrates and the decomposition of carbonates. These are the two equations for group two. Now, what he's asking for is that he's saying that cement works, they roast 1,000 million tons of limestone per year, and a further 200 million tons is roasted by kilns to make lime. So, what is the total annual mass output of carbon dioxide? That's what they're looking for. So, how much total limestone is being roasted? That's
1,000 million.
that's 1,200 million, like 1,000 million over here and 200 more.
Okay.
So that's 1,200 million tons, right? So they're asking for the mass of carbon dioxide. What I'll do is I'm not going to take it as 1,200 million tons. I'm going to think of it as grams. Whatever answer that I get, I'm going to refer to it as million tons. Okay, just to simplify, because converting million tons into grams, that's going to take some time. So what's you can find the moles of this. You can find the moles of carbon dioxide. He's asking for the mass of carbon dioxide. So find the moles of calcium carbonate and tell me what are you getting? And tell me the MR as well.
For the MR, I got 100.
Okay, so that means basically 12 moles, right?
Yeah.
So you have 12 moles of these. And what would be the moles of carbon dioxide then?
12.
Okay, they're going to be 12 as well. So now what you have to do is you have to find the mass.
I got 528.
Okay, so that's fine. That's probably this one. 527. The reason it's 527 is because we're taking calcium as 40. Calcium is not exactly 40, it's actually 40.1.
Okay.
So anyways, this question is you have to check each statement whether it's correct or not. Now he's saying that 3.27 grams of zinc is giving you the reaction. Like look at the first statement. There's 3.27 grams of zinc. Can you find the moles of zinc?
I got 0.05.
So you got 0.05 moles, right? Exact.
Yeah.
So you're getting 0.05 moles of zinc. So he's saying that zinc reacts with an excess of hydrochloric acid to give 0.05 moles of zinc chloride. So according to this ratio, how many moles of zinc chloride would be formed?
0.05.
So this statement is correct. Because the first statement, first option is correct, right?
Yeah.
I said, what about the next one? Now he's saying that in the next one, let me rub this off. Uh, now the second statement is that we need to figure out whether that's the right statement or not. The second statement is that now you have 6.454 grams of zinc, right?
Yeah.
And you're being asked that it reacts completely with 100 cm cube of zero point 0.1 mole per dm cube hydrochloric acid. Can you find the moles of zinc?
I got 0.100.
So you got 0.01 1 moles,
Yeah.
right?
Yeah, 0.1.
0.1.
Yeah.
Okay, so the amount of HCl should be, according to this ratio, what amount of HCl should you get?
1 mole per dm cubed.
Nee, it's 1:2.
Oh, so you get 0.2.
So he's saying that it's reacting with 100 cm cube or 1 mole per dm cube hydrochloric acid. Can you find the moles of hydrochloric acid over here?
100, right?
Nee, but you have to divide by 1,000 as well. Like,
Oh, yeah. Or 0.1 then.
so you're getting
0.1.
TK, which is not correct because you should be getting 0.2, right?
Yeah.
I mean, that's what you figured out, that it should be 0.2, which means that this is wrong. This statement is incorrect because it's not going to be 0.1 moles. So the second statement is wrong. And can you now also figure out whether the third statement is correct or not? Now you have 13.08 grams of zinc. How many moles is that?
0.201.
Is 0 point?
0.201.
I think 0.2 moles.
Yeah.
So how much H2 should be produced in moles?
0.4.
It's going to be 0.2. It's the same moles.
0.2.
Like H2 and zinc, they have the same. It's one H2, one zinc, right?
Okay.
How do you find the volume of the gas? Like you have the moles.
Um, it would be like, I think you would do like moles divided by concentration.
Then it's a gas. For gases, the formula was, what was the formula for gases? It was moles is equal to volume of gas divided by 24 dm cube.
Okay.
So you multiply by 24. How much do you get?
4.8.
So you should be getting 4.8, not 9.6, which is why this one is also incorrect.
Okay.
So now the next question is, let's leave this as well. I mean, this is a repeat. So now this one. Now he's talking about the decomposition of magnesium nitrate, which is going to be exactly the same equation. Like MgNO3 twice, it would decompose to produce MgO plus 2NO2 plus half O2. Can you just hold on 1 second? I have to take a call.
Okay, that's fine.
Now, this question, TK, we have magnesium nitrate, and it's the same equation exactly. All nitrates decompose, group 2 nitrates would decompose in the same way. Now he's saying 7.4 grams of anhydrous magnesium nitrate. Anhydrous means that there is no water. So this is 7.4 grams, right?
Yeah.
And he's saying what mass of X is produced. What is X? X is one of the gases, is an oxide of nitrogen. So he's basically wanting to, he's asking for the mass of this substance. So can you find the moles first of, I mean, obviously magnesium nitrate. Did you find the MR?
Yeah. Um, I got 148,
So you got 100 and
48.
that's fine. So divided by the MR, it's going to be 148. How many moles would you get?
I got 0.05.
So that's 0.05 moles. What's the moles of NO2 now?
Like 0.1.
TK. And what's going to be the mass?
I got 6.
Six. Like this was, what is the MR of NO2?
I got 60.
It's not, I mean, it's N, one N, that's 14, plus two oxygens. So that's 16 plus 16, so that's 46.
Okay, I got 92.
Again, why are you getting 92? Remember, when this 2 should not be included in anything
Okay.
because this 2 is the ratio. I mean, if you're comparing this with MgO, I mean, this is the ratio of the moles with respect to all the others. Okay? It has nothing to do with the MR.
Okay, I got 46.
Times 0.1. So it's going to be,
4.6.
it's going to be 4.6 grams. Let's, this is again magnesium nitrate decomposition. And we can ignore this. Now this one, let's do this one. He's asking you to calculate the mass of barium oxide, right?
Yeah.
So you need to find the mass of this thing. And what you have is 5.4 grams of aluminium. So you're given the mass of this. This is 5.4 grams. So can you find the moles of aluminium?
Yeah. I got 0.2.
0 0.2 moles for this. Okay, that's fine. And what's the moles of barium oxide now?
I got 0.06.
Moles?
Yeah.
How would you find? I mean, the ratio would be 0.2 divided by 10 into 3.
So that's what I did.
I mean, what's 0.2? 0.2 divided with 10 into 3.
I got 0.06. 06.
0.06?
Yeah,
Okay, I think that makes sense. Yes, 0.06 moles. Then find the mass.
I got 9.18.
Okay, that would give you okay, when you calculate the MR, make sure
Yeah,
don't use this 3.
okay.
It's 137 plus 16, right?
Yeah,
Okay, that's so now more than gases. Now you have to find volume of gas, right? So you're given that a typical driver. This is, I think, sodium azide. This is this is 50 grams, right?
yeah.
And you're being asked to find the volume of nitrogen gas. You have to calculate the volume of nitrogen that this will produce. So find the moles of Na3.
I got 64 for the MR.
64. Oh, that's 23 plus 14 plus 14 plus 14. That's 42. 64?
Yeah,
I mean, what's 42 plus 23?
six. Yeah, 64, right?
That's 65.
Or is it? I'm not sure. Oh yeah, I
Okay,
don't want. Yeah, I think I added it wrong.
so it's 65. TK, that's the MR. Find the moles of Na3.
Oh, okay. Oh, because I put the value as 22 of Na.
That's
That's
a
why.
TK.
So for the moles, I got 0.76.
0.76.
Yeah.
Okay, so you can find the moles of how many how many moles of N2 then?
I got 1.15.
1 point?
15.
Yeah, that's fine. And how would you find the volume of the gas? What's the formula?
Um, like moles equals concentration times volume, right?
Nee, that's for solutions. For gases,
Um,
like volume of a solution is a separate thing. Volume of gases is completely separate thing. So you have to use the 24 dm cube thing.
I got 27.69 here.
So it's going to be C, right?
Yeah, because it's round up.
Okay. Now this question is, I say he's saying that a gas is occupying 3 dm cube. And he's saying assume that, I mean, the 24 dm cube thing, you can use the formula. So there's a gas that occupies 3 dm cubes. So which one of the gas do you think is this gas? How do you do this?
Don't you have to find out how many moles is in each gas first, I think.
Okay, that's the first thing you do. How many moles is this? 3.2 grams of oxygen.
That's like 0.1, right?
Is 0.1 moles? Yeah, I think it's,
Yeah,
yes. And you times 24, you'll get the volume, which is going to be 2.4 dm cube, right?
yeah.
So that's not 3 dm cube. Try and do this with the other gases.
Oh, it's C?
It is C. Because that gives you 1 by 8 is the moles, 8 divided by 64 times 24 dm cube, and that would give you 3. Okay, let's see. So let's see if we can have. Let me ignore this. Ignore this. Now this question, I'm going to talk about this question a bit. One thing that you should know is, for example, if you have this question, right?
Yeah.
Let's say I give you a question where you have to find. I mean, all of them are gases. Okay, remember, learn to differentiate between the volume of gases and the volume of solutions. So we're talking about gases here. Let's say I tell you that 20 cm cube of nitrogen is reacting. How would I find the volume of the other substance? What's the first thing that you're going to do?
And you first work out the moles of nitrogen, right?
Okay, tell me what the moles are. It's going
Is it 0.83?
to, no, this is cm cube, so you have to divide by 24,000.
Oh, okay.
Or you can convert that into dm cube.
So is it zero zero point 0.00083?
Two zeros, three zeros after the decimal.
I got three.
Okay. And 833 moles, right?
Yeah.
So if I had asked you to find the moles of NH3, how many moles of NH3, how much would be the moles of NH3?
Um, I guess I times that by two and three.
Yeah,
So it's like 0.0016.
7 moles, right?
Yeah.
And find the volume, you're going to multiply it by 24 dm cube, right?
Yeah.
So what is the volume that you're getting? Or multiply by 24,000 so that thing comes in cm cube.
Okay. I got 40.08.
Okay, it's approximately 40 cm cube, right?
Yeah.
So now, the easier way to do this question, no need to calculate moles. Okay, your answer was 40 cm cube, right?
Yeah.
Remember for gases, and this is only for gases, TK, when you have gases in an equation, mole ratio and volume ratio is exactly the same. So if it's 1:2, that's the mole ratio, right? The
Yeah.
volume ratio is exactly going to be the same. It's going to be 40 cm cube. Okay, is that clear? No need to calculate anything.
Okay.
But this only applies to gases. You can do the moles things, uh, and that will give you the correct answer. But there's no need for the calculation. Okay, for remember for gases, the volume ratio and the mole ratio is going to be exactly identical. So what would be the volume of H2 that's reacting in this?
Um, so would it be 60?
Why 60? This is 1:3, right?
Yeah, so you would either do 20
No,
times 5.
no, TK, you're right. You're right. It's 60. TK, so it's going to be 60 cm cube. So remember, for gases, mole ratio and volume ratio is exactly the same. You don't have to calculate moles. You don't have to do any sort of calculation for that. So let's say this is methane thiol, and he's saying that 10 cm cube is reacting, and all of them are gases, like except for the last one, I think, because it's happening at room temperature. CO2 and SO2 are for sure gases. Uh, Now tell me how much O2 would react with it.
Um,
1:3.
30?
So it's going to be 30, right?
Yeah,
And how much CO2 would be produced? 10, right?
yeah, 10.
And SO2 would also be 10.
Yeah.
But this thing wouldn't apply to water because water is not a gas, right?
Oh,
So the question is, 10 cm cube of methane thiol was exploded with 60 cm cube of oxygen. So which one is in excess? Like you just need 30 cm cube, right?
yeah,
So that means only 30 cm cube would react. There would be 30 cm cube of leftover oxygen, right?
yeah.
And he's saying what would be the final volume of the resultant mixture of gases. So the resultant mixture of gases is going to be that there is 10 cm cube of CO2 and 10 cm cube of SO2, plus there's 30 cm cube of leftover unreacted oxygen. So the total volume is going to be
50.
50. TK, is that clear?
Yeah.
TK, just remember, and the ratio, and this ratio thing only applies to gases. So if there's a solid or liquid, you can't really do much. You have to do the old-fashioned way. You have to find the moles, and then you can find the moles of everything in the equation. But if you're just comparing gases, no need to find moles.
Okay.
Chalo, ठीक है. Amal, we're going to continue with this, ठीक है, in the next class then.
Okay.
Okay, take care.
Bye.
Hafiz. Bye bye.